Page 5 of polynomials, number 4. Use your GDC to sketch this graph for x is between negative 10 to 10. Find the value of f of x when x equals 8. Okay, so we go to y equals, we're going to type in the function. Cleaning out the functions. Okay, we're going to put in 3 plus 6 divided by x. It's always good to put in parentheses when you're in doubt about PEMDAS. In this case, I would go ahead and put it in. They give you a good hint here. They say that they want to graph it between negative 10 and 10. Now, when you graph it, it usually automatically does between negative 10 and 10, and if it doesn't, you want to go to Zoom Standard. Zoom Standard does between negative 10 and 10 on the x-axis and on the y-axis. Usually that's a good place to start. Okay, so they want to know what is the value of x, what is the height when x equals 8. So there's a couple ways to do that. One is second table, and then we'll go down to 8, and we see that it's 3.75. And the other way to do it is to go to the graph and do trace and type in x equals 8. Just type in 8 and it'll give you the point 8, 3.75. C, find the value of x when y equals 5. There's a couple ways to do that too. One is you go here, oh wait, look, second table. So we see that 3, 5 is a value. So x equals 3 when y equals 5, right? The other way to do it would be to draw a second line here. I'm going to draw a line at y equals 5. And then I'm going to graph it. And then I'm going to see where this intersection point is. Second calc, intersect 5. First curve, yes. Oh, I need to move a little bit. First curve, yes. Second curve, yes. Guess. Doesn't matter where, because there's only one intersection point right there. I don't need to move it around. I just need to press enter. 3, 5. There it is again. Okay? So when y equals 5, x equals 3. Two ways to do it. Write down the equations of the vertical and horizontal asymptotes of the graph. Remember that the vertical asymptote you can find by this guide here. X is not equal to 0. It's warning you, hey, x is not equal to 0, so there's an asymptote at x is equal to 0. So you could say, oh, the vertical asymptote is x equals 0. Okay? Another way you might do it is, hey, what value of x would make this explode? If you put 0 in for the denominator, 6 divided by 0 is, if you do it on a calculator, you'll see error, but it's also known as infinity. So that's also a way to figure out that x equals 0 is the vertical asymptote. What about the horizontal asymptote? Horizontal asymptote, you can look at table, and you could just like go out as far as you can go, and you see that it seems to be approaching the value 3, right? Here. So probably the value is 3. Okay, for the horizontal asymptote. Oops. Write it down here. Okay? Alright, last question. Given that the domain of f is the real numbers and x is not equal to 0, write down the range of f. Okay, so let's go back to the graph again. Alright, so we know that this function kind of looks like this, and it's got horizontal asymptote at y equals 3. We draw a dotted line there. Write down the range. So the range is any possible y, all possible y values for this function. So you can see that it can pretty much take on any y value, right? Looks like this function goes on forever going up. It goes on forever going down. So ranges from negative infinity to infinity. Is there any value which it cannot take on? Oh, wait a second. It cannot take on this value, the asymptote value, which is related to y equals 3. So actually the range is going to be y is all real numbers, but y is not equal to 3. It's the opposite of the horizontal asymptote. Okay. That was number 4. Now we're going to do 4x number 1. One section of a roller coaster ride can be modeled by the equation 20 over x plus 2x squared, where x is not equal to 0. Where x is the time in seconds from the start of the ride, and f of x is the speed in meters per second. Use your GDC to sketch the graph of the function for x is between 0 and 10, and find the minimum value of the graph. Okay, so let's go to function. We're going to clear it out. Then we're going to put in the function here. And again, I would put parentheses around this 20 over x. Okay, and let's say 20, parentheses 20 divided by x, plus 2x squared. Okay, now I'm going to graph it. I'm going to sketch the graph between 0 and 10. Oh, it's giving me a little guidance as far as what I could do with my window. So my window, I'm going to put 0 to 10 for the x. And then maybe I'm going to adjust the y-axis by doing zoom fit. So zoom fit. Okay. Ooh, it redid it. Okay. So what does it look like? It looks kind of like this. Okay. Find the minimum value of the graph. So the minimum value would be this point here. Okay, so the minimum value, of course, we find with second count minimum. And we're going to put the left bound slightly to the left of the minimum. I can't even see it. Oh, there it is. It's right there. Enter. And then we go a little bit to the right of the minimum. There we are. It's right there. Enter. And the guess can be anywhere. And it says it's 1.71, comma, 17.5. Okay, so that is the minimum value right there. And we could just give the coordinates there. Okay, find the speed when x equals 6. So when x equals 6, remember the speed is the y. So let's look at the table. That's the best way to find the speed. Okay, so we're way up here because we're looking at the asymptote. We're going to look at x equals 6, and we're going to see what y equals when x equals 6. It equals 75.3. Okay, and then D. Find the times when the speed is 50. When the speed is 50. Okay, looks like the speed is 50 between 4 and 5. So one of the things we could do is we could do a plus 0.1. See the step side a little bit smaller. And then we could say exactly when it's 50. Ooh, that's pretty close, isn't it? So like 4.8. And we could break it down even more. We could go plus 0.01. And then we'll get a more exact number here. So 50. Oh, there we go. So maybe this one here, 4.79. So 4.79. And then there's probably one other place that's like that. Let me reset the table. Again, I'm going to go second table set. Table start 0. Delta table 1. And then get out. And then I'm going to go back to the table. And then I'm going to find the other place that maybe it's about equal to 50. Oops, I went past it. So one of the places was 4.79, right? And the other place, ooh, it's here. It's between 0 and 1. Let's see. Plus 0.1. And then we can see 0.4 is pretty close, right? Plus 0.01. We're going to get an even closer number. Actually, 0.4 is pretty close. Okay, so we'll put 0.4. Okay, so one of the other times is 0.4. Now I'm going to show you another way to do that. The other way to do that, let me just restore table set to be what it was before. Table start to 0, delta table to 1. And then we're going to go back and do a different way. So we have the function in y1. For y2, we're going to put the value of y that we're looking for, which is 50. So we're going to say y equals 50. So we're going to compare the function, which is a horizontal line, y equals 50, with the original function. And then they're going to cross, and the two places where it crosses, we're going to find out what the x value is. So here and here. How do we find the x value? We're going to do second calc intersect, because that's going to find us the coordinates for each one of those. So first curve, yes. Second curve, yes. And then first we're going to find this one. It's closer. And it gives us 4.79. Yeah, that's the first value we had anyway. Then we're going to do it again. Intersect. And now we're going to do first curve, yes. Second curve, yes. And then we're going to move the cursor now close to the first point. Enter. And the intersection is 0.403. So that gave us one more digit, right? A little bit better. Okay? Okay, I actually wrote here a hint for part D. Program another function y equals 50. Then find the intersection using second calc intersect. Okay? Alright, let's move on to 4y number 1, which is it the last problem? Yeah, it's the last problem on this page. Consider the function 1 plus 2 over x. So we're going to put that in. 1 plus 2 divided by x. And then we're going to delete that one. Okay, 1 plus 2 divided by x. And when we graph with zoom standard, this is how it looks. Okay? And then it asks us to complete the table. The best way to do that is to do second table and get the values from here. So 0 is an asymptote, okay? And then the other values have certain numbers. Some of them are nicer than others. 32, 1.67, let me make this bigger. 1.5, 1.4, 1.33, and they're skipping numbers. Be careful. 4 is 1.5. 5 is 1.4. 10 is 1.2. Okay, what about the other side? Negative 10. Negative 10 is 0.8. Negative 5 is 0.6. Negative 4 is 0.5. Negative 2 is 0. Negative 1 is negative 1. Negative 0.5. Ooh. How do we see that? We're going to do plus 0.1. We're going to see that. Negative 0.5 is negative 3. Negative 0.2 is negative 9. Right? Okay. Now that we have all these values, we can draw the graph. Use a scale of 1 unit to represent 1 centimeter on each of the axes. So we're just going to use one of these squares for each. So I'm going to draw the axes here and here. Okay, draw the vertical asymptote. Actually, the vertical asymptote is right at 0, so I'm going to draw it with blue. Dotted line is blue. Okay. Write down the equation of the vertical asymptote. It's x equals 0. It's the opposite of x is not equal to 0, right? Draw the horizontal asymptote. Okay, the horizontal asymptote, you may have picked up the trick already. The horizontal asymptote is this number that's isolated here. But if you don't know that trick, then what you could do is you could just go to the calculator. We're going to change the table set so that it starts at 0 and jumps by 1s again. We can graph it, and then we'll look at the table. If we look at the table, we can zoom down here, and we can see what whole number does this thing approach. And it looks like it's approaching 1, right? So let's say that the horizontal asymptote is 1. We write y equals 1 because the horizontal asymptote, you always write y equals something. And then you write down the equation of, we already wrote down the equation of the horizontal asymptote. Now we're going to draw the horizontal asymptote here. Y equals 1. Okay, now we can graph some of these points. We're doing it a little bit backwards, maybe. It said to draw the graph here, but we drew the asymptote first, which actually makes more sense to draw the asymptote first. Okay, now let's graph some of these points, like negative 10, 0.8, negative 5, 0.6. They're, it's really hard to see the difference between these, right? Negative 2, 0. Negative 1, negative 1. Oops, I drew that one in the wrong place. Negative 2, 0 is here. Negative 1 is here. Oops. Negative 1 is here. 0.23, 0.2, 3, there. 0.52, there. 1.67, there. And then now there's just a bunch of points that are like very similar. Okay, it's kind of hard to see those. And then I'm just going to use a pink here and kind of connect everything with a curve. That's the way that looks. And now you can see why they didn't really ask us to do like every single point between negative 10 and 0, because they like all come out to be pretty much the same. Alright? And I think that's it for this one.